Hi everyone, this is Matt Teachout with Intro Stats, and today we're looking at a problem from my book. This is section 3C, number 36. So this is in the section on p-value, so it's really just about interpreting p-value, which is a really important part of a hypothesis test. So let's read the question together. It has long been thought that the population mean average body temperature is 98.6 degrees Fahrenheit. A study is now claiming that the population mean average body temperature is really lower than 98.6. A random sample of 50 adults worldwide was conducted and the average temperature was 98.26 degrees with a p-value of 0.0014 was found. We're using a 1% significance level. The null and alternative hypotheses are given below. So again, one of the things that students often have trouble with is, am I calculating something or am I interpreting something that's already been calculated? You can kind of see in the problem, they're not asking us to calculate anything. They're just asking us to interpret these numbers. The p-value is already calculated. So what we're doing is we're just interpreting and kind of making sense of these numbers, which is really the important part of statistics. Remember, I keep saying the computers calculate and we interpret, right? We tell people what the numbers mean. So let's read the first question. If the null hypothesis was true, what is the probability that the sample data or more extreme occurred because of sampling variability? That should sound very familiar to you. The probability that the sample data are more extreme because of sampling variability is the definition of p-value. So question A is really just a kind of a tricky way of asking you what's the p-value, but seeing if you really know what the p-value stands for. So the p-value is up here in the problem. It was already calculated, 0.0014. So that's the answer to letter A. So let's write that down. Letter A is 0. So it's really the p-value, and it's 0.0014. Now if we wanted to convert that into a percentage, we could go ahead and multiply by 100 and we get 0.14%, which is very small, close to 0. Okay, so question A was just asking what's the p-value? All right, question B, write the standard p-value sentence to describe the true meaning of the p-value. Okay, let's do that. So it's really, again, when they ask you to describe the p-value, they're really just asking for the definition of the p-value. So if the null hypothesis, this is a definition that you really want to know, is true, there is a 0.14% chance or probability of getting the sample data or more extreme by sampling variability. Or you could say by random chance. All right, so letter C, we're just writing down the definition of p-value. All right, let's look at letter C. Was the sample data significantly different from the population parameter in the null hypothesis? In other words, was 98.26, that was the sample mean, significantly different from 98.6, which was in the null hypothesis, right? We see that number 98.6. Again, this is why you don't want to trust your gut, right? If we just looked at those two numbers, you might think they're actually close, but they're really not. This low p-value would only happen if the test statistic fell in the tail. So this is really telling me significant. Remember we said a low p-value means significant difference. So this low p-value is telling me that they are significantly different. And how do I know it's low? Well, 0.0014 is lower than 1%. 1% is 0.01. So this is definitely lower than the significance level. So it's a low p-value. And we learned in this section that a low p-value, so since the p-value is lower than the significance level, the sample statistic or sample data significantly disagrees with the null hypothesis. Or you could say that the 98.26 really disagrees with the 98.6, right? In this case, what they're talking about is the 98.26 degrees Fahrenheit significantly disagrees with the 98.6 in the null hypothesis. Okay, so again, a low p-value gives us the similar information as a test statistic falling in the tail. Tells us that the sample data significantly disagrees with the null hypothesis, or the sample statistic significantly disagrees with the parameter in the null hypothesis. All right, let's look at the last question here. We're almost done. Should I reject the null hypothesis or fail to reject? Again, we see here that the p-value given to us was very close to 0, which is the way we like it, and it's much lower than the significance level. So what did we say? A low p-value means we reject the null hypothesis, right? It's unlikely to be sampling variability, and we're going to reject the null hypothesis. Actually, I guess I did D and E together. So letter D is, could the sample data have occurred because of sampling variability, or is it unlikely? Again, the p-value was very close to 0. When you have a 0 probability, that's very unlikely. And we said that we're going to reject the null hypothesis. So letter D, since the p-value is lower than the significance level, it is unlikely that this sample data or sample statistic occurred by sampling variability. And remember, we said there's only two reasons why the sample data disagrees with the null hypothesis. Either the null hypothesis could be right and the sample data disagrees because of sampling variability, or the null hypothesis could be wrong and it's not sampling variability. So since this is not sampling variability, that's what allows us to reject the null. So since the p-value is lower than the significance level, we will reject the null hypothesis. By the way, that kind of leans towards us supporting the alternative hypothesis, but that's when we get into writing a conclusion. This really didn't ask us to write a formal conclusion yet. That's the next section. So, all right, so there it is, section 3C, number 36. Again, there was no calculation involved. We just had to sort of interpret these numbers that were already calculated for us. All right, so I hope that's helpful for you. This is Matt Teachout and Intro Stats.